So distance AB. What is it? One line. You're doing one line, right? One line, guys. Come on. What kind of triangle is this? It's just a right angle triangle here, right? And that's A, and that's B, right? Okay, I think that's fine. All right. But what do I do with this? Where do I go with it? Now, one suggestion was perpendicular distance formula. Okay. How would I use it? How would I go about using it? This is the perpendicular distance formula. Just don't forget that the A's and B's and C's here are not the A's and B's that we have here, but that's the general form. What am I going to do with it? What would I input into it? Okay, all right. So I know what this distance is. Okay, so I can pop that in. Okay, and then on the right hand side, let's see. This A and this B and this C. Where are they going to come from? Where are they from? They correspond to the coefficients, don't they? This I'd have to put in general form, I guess, but I could get that. That'd be fine. Okay. Then I'll try and solve. Okay. Now, can anyone see? There's going to be a problem as I do this, right? This is fine, the A squared and the B squared. The A and the B and the C are also fine, but there's going to be a serious problem. Can anyone see it? I can come up with different letters to account for them. I mean, we could call them different things so that they don't overlap. Let's assume we get our labeling right and they don't clash. There's a problem solving issue here. There's a problem with this method. Can anyone see it? The absolute value will complicate things, but thankfully, because I know where everything is, I can say I can know what's going to be positive, what's going to be negative, so I should be able to get rid of a whole lot of cases that way. So I think I'll be okay there. Let me ask you a question. How many variables am I solving for when I get this equation in the right form? How many variables? I'm solving for 2 variables, aren't I? The x and the y. This is what I'm expecting for x, and this is what I'm expecting for y, right? How many equations do I have to solve for these 2 variables? I've just got that. That's all I've got at the moment, okay? So I'm in trouble. I can get down to something simple, but I will not get just one answer out for my points. I need something else to help me out, okay? What am I missing? Now, I'm gonna let you file that away for a second. Part of the problem is our choice of the way you'd go about this. The perpendicular distance formula is complicated, okay? And it's got x and y built into it already, okay? So what I'm gonna do is, I'll just leave this off on the side and suggest another way that we could use this, the distance, okay? And this, the equation of the line to find out what these coordinates are, okay? Now, first, part of the problem you guys keep saying is, can I just sub this in? Can I put it in and just start working with it, okay? That's a natural instinct to have, but I can't do it, right? Because I don't know that's the case yet. However, I can give it some name, and then I can start working with it, okay? Even if I don't know exactly what it is, okay? So I'm looking for an x coordinate and a y coordinate. I've got a whole bunch of x coordinates and y coordinates, right? So that I'm not ambiguous, I'm going to call it xd and yd. Okay, so these are what I'm trying to find. Okay. Now, the reason why this is useful to me is because now I can take this equation and I can sub some things into it, right? Because that set of coordinates ought to satisfy this equation. Yeah? Is that okay? So I should be able to say this. Okay? Yeah. Is the equation of DE the same as the equation of AB? Okay, sort of, but be careful, okay? Because this distance that you've got here is often an angle, right? But the distance, if you want to add, if you want to have like a vertical shift, you need to know what that distance is, right? So I guess that'd be plus plus b, but you have to show that, right? I have to establish what this distance is. And you can do that in a variety of ways. I'm doing one of them, right? So I see what you're getting, but we're still trying to use information we haven't proven yet. All right, now, maybe I'm working so that I don't lose what I'm up to. Okay, now, I've got these statements here, right? What I'm really trying to link is distance and gradient. Those are the keys, okay? So here, even though what you've got is the equation of the line, I think it'd be nice if I just get an equation with relating x of d and y of d, because then I can eliminate one of them, okay? So if I rearrange this a little bit, I think probably a nice, helpful way to write it would be like this. Let's see here. We've got it like this. I think I've just flipped that around. Is that right? Yeah, good. Okay. Now, the reason why this is going to be helpful for me is because this guy will appear in a second. Just watch for him, okay? Where's he going to appear? This is my distance AB, right? Distance AB. But I know it's the same as another distance. Which one? DB, that's the one I'm after, right? So I can say distance BD is equal to the square root of a squared plus b squared. But I know another way to find the distance of BD, right? What is it? It's just from here to here. And I know those 2 points, right? So what's going to be here on the left-hand side? Well, it's x2 minus x1 and plus y2 minus y1, both squared. Yeah, Pythagoras. Okay. So I'm going to have, which points are we going to match up? x2 minus x1. See that? x2, x1. Yeah. Squared plus y2 minus y1 squared. Is that okay? Can you see where I got those 2 points from? That's b and d. Okay. That's equal to this. Okay. Can you see what's about to happen? Can you see what I'm about to substitute? Okay. See that xd minus b, that's right there. I knew it was coming because when I was going to work out this distance, you're going to have to subtract these x coordinates somehow. Okay. So now if I substitute that out, and I'll be lazy, I'm going to square both sides at the same time. Okay. So I'm going to have this yd minus, yd a on b, all squared. That's that substitution there. Plus, that 0 disappears. Now I have this, okay? It looks messy, but it's not that bad, is it? What should you do? What step would you do next? What's our goal? By the way, what are we trying to get out of this equation? yd, right? The y coordinate of d. So what should I do? I should factorize, right? Because that's going to be the quickest way to make yd the subject, yeah? So what should I factorize out? I can probably do it twice, right? yd squared. So yd squared, okay? What am I going to be left with? A squared on b squared plus 1. Yeah? Is that okay? Right? Kick that guy over the other side. Okay, now, I've run out of space here. What would you do here, though? What's the quickest way to get out of this? Say again, James? Yeah, perfect. That'll get rid of these. If I multiply by b squared here and here, b squared, multiply, okay? That's going to simplify this fraction down the bottom, right? So I'm going to get yd all squared. I'll leave that there for a second. Now what happens to the bottom? A squared and b squared becomes a squared, and the 1 becomes b squared. Sorry, plus. Okay. Cancel, cancel. Okay, now what? Be careful. Good. So they're both squared. So I have 2 set solutions. But what do you say next?
yd is only equal to positive.
think your logic was exactly right and your answer was wrong. So hold on a second. We established earlier B is negative. B is negative, but YD is above the axis, so that's positive, right? So I would say, I'd probably say both of those. Okay? Therefore, contrary to normal, right, the answer we're going to exclude is the positive one. Yeah, I think that's what you meant to say. Okay. Too many minus signs. All right, done. There we go. There's the y value. That was the hard part. How am I going to get the x value? Where am I going to put it into? What's the best place? Probably this one, yeah? I probably should have named that earlier so that I could have said here. So now let's come back to it, okay? Substitute into 1. What are we going to have? xd minus b equals minus b times a on b. Get this guy over. And these two cancel. And I'm home. Hooray. Okay. Happy with that? Now, you can apply the same logic and you'll get the next part. Before I move on to part C and part D, what was the other way we said we were going to do it? What was our other alternative? Yes, you do a triangle. Okay. Now, I'm not going to rehearse it fully because it takes me too long to write, but let me show you how it would work, and you decide which one is better. I'm kind of in two minds. This is a little more difficult algebraically. It's kind of like, multiple times I looked at you and you were like, I don't know what to do next, okay? But writing out all the geometry, if you're going to have triangles and stuff, you're going to have to prove congruence. You're just going to have a lot of words, right? So if you're okay with writing all that and you want a more straightforward, logically proof, then go that way. Here's how I would do it. I need to make a triangle over here, okay? So I'm going to say let point P be the point on the x-axis directly beneath D. Yeah, you have to make a new triangle somehow, okay? Once you've got point P there, if you name some of your angles over here, so for instance, let A be H equal theta, that's 90, what's this going to be? 90 minus theta. Okay, but again, you can't just write all of these numbers down, you actually have to say why. So you have to say angles on a straight line add up to, okay? If that's 90 minus theta, what's this up in the corner? Theta, okay? So now you've got angle, 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 side, side. So you can prove congruence. Okay? Once you prove congruence, you can say, well, look, this side is side B. What does it correspond to? It has a name, PD. So you can say that's B. But you have to be careful because you have to explain why actually the coordinate will be minus B, because again, B is negative. Okay? And you can use exactly the same logic. You can say, look, this corresponds to this side, so that's A, and the x coordinate of this is really the whole lot. If this is B and this is A and B is negative, and the whole thing should be negative because it's the left of the axis, that's where you get your B minus A from. Okay? So that went quickly because I just said it instead of writing it, okay? But I wrote them down, I wrote them both down. Right, okay, so there's my diagram, I suppose that takes up a lot of space. We're all the way up to here. Okay, so it's basically a full page. That's how long it takes you to explain the geometry to do with this triangle. And you can compare that to, from here, that's my second proof. So there to, probably shouldn't have stapled these, hey? Up to here, so it's about the same length. It's just not as wordy, okay? So if you prefer the algebra and you just hate geometry reasoning to death, then this way that I've showed you is probably the way to go. Any questions? Was that good, huh? Okay, now the rest of the question, I think falls out relatively easy after that. That's why there are far less marks to do with it, okay? Part B, you have to find the coordinates of f in terms of A and C, which is exactly the same process. So in many ways you can say similarly. And then from there, part E, how do you show that things are concurrent? What do you think is the best way to do it? Yeah. Yeah, so in fact, parts C and D, you have to find this equation, that green dotted line, and that one. After you know those equations, right, especially since you already know in advance, where they're going to concur is on the y-axis, right? So you've got a nice easy value to sub in, namely x equals 0, right? So sub it in for all three of the lines, or only two of them, because AH is the y-axis. And you'll show that they all pass through this one point, and the coordinates are quite easy to find.